Okay, so student, now we are going to start the MCQ section in that chapter as your oscillation. So in your MCQ, that is in exercise, your first question is MCQ, page number 129. And in that, your first MCQ is, just concentrate, a particle performs linear ascension starting from mean position. Its amplitude is capital A. Time period is capital T. At the instant when its speed is half of the maximum speed. Right? So its speed of particle performing ascension formula is V is equal to omega under root of A square minus omega square. This is the speed of particle when particle is performing ascension. This speed and your maximum speed. So when particle is performing ascension, its maximum speed is equal to A. Now in this MCQ, you have given the relation between speed of particle performing ascension and the maximum speed of the particle. What relation they have given? At the instant when the speed is half of the maximum speed. So this speed is half of the maximum speed. So what I can say that this V max is equal to half of speed at any instant. Now we are knowing that this V max is nothing but A omega, which is equal to half the value of V is omega under root of A square minus X square. So from both sides this omega factor will get cancelled. And this 2 factor I will shift it here, so I am getting here 2A, which is equal to nothing but under root of A square minus X square. Right? I want to find out the displacement. So what I do? I want X value. So I square both the sides. So I am getting this 4A square, which is equal to A square minus X square. And I want displacement only. So this, what I will do? This X square term, I am going to shift it here. So what I am getting here, this X square will become minus here. So I will write down this X square is equal to nothing but as your 3X square. Fine. And now using that, I can find out the here as a M. Is it right? Here what happens here? Here it is nothing but half of the speed. So here half of the speed is this. So I get the equation. Get it? So this is nothing but your answer A. So here I am getting the answer A. Then your second MCQ. A body of mass 1 kg performing linear ascension. So mass of the body is given as 1 kg. It is performing ascension. Its displacement x is in centimeter. At time t is given in second. Is given by, you have given displacement x is equal to 6 sine, the equation is given sine 100 t plus is pi by 2. Clear? And you want to find out the maximum kinetic energy of the body. So maximum kinetic energy. So K max is equal to half mass V square max. Right? And you are knowing that when particle is performing ascension, its V max is nothing but equal to A omega. Means I have to find out first A omega. A is amplitude. Omega is nothing but the angular speed. Now how I can find? A and omega I can find out from your given displacement equation. This x is your displacement equation. This displacement equation I will compare with the standard displacement equation of a particle performing ascension. So x is equal to A sine omega t plus I. So this is my standard form of displacement equation. This is my given displacement equation. If I compare equation 1 with 2, so see here left hand side xx is equal to right hand side 6 and here is the a. Means value of amplitude A is equal to 6 meter. In the problem you have given that displacement is in centimeter, therefore A here I am getting as a 6 centimeter. Then sine. In the both equation we have a sine. In bracket 100t and here is the omega t. This omega value is equal to 100. Right? Means I am getting value of A, I am getting value of omega. Using that, I can find out Vmax. So I'll write down here Vmax is equal to 6 centimeter. Centimeter I will convert into meter. So 6 into 10 raised to minus 2 multiplied by 100 means I am getting this Vmax is equal to nothing but 6 meter per second. And using this 6 meter per second, now I can find out the kinetic energy. So kinetic energy maximum formula already I have written. Kinetic energy max, K max is equal to nothing but half mass of the body is 1 and V value is nothing but 6. So 6 square is nothing but the 36. So this 2 and 36 will get cancelled. So I am getting here 18. So what I am getting is kinetic energy maximum is equal to nothing but 18 and it is energy. Energy means it is unit is joule. So this is nothing but your second MCQ answer. That is kinetic energy maximum is equal to nothing but 18 joule. That is your option number B. Clear? Okay, fine. Next, now third MCQ. The length of second pendulum on the surface of Earth is nearly 1 meter. So you have given the length of simple pendulum, length of second pendulum is given as a 1 meter on the Earth's surface. So L is the length on the Earth's surface. So E, it is equal to 1 meter. It is given. Its length on the surface of Moon should be. What will be the length of that second pendulum on the surface of Moon? If acceleration, gravitational acceleration on Moon is 1/6 of the gravitational acceleration on the Earth's surface. It is already given in the MCQ. This relation is given. What? Gravitational acceleration on the Moon surface is equal to 1/6 of gravitational acceleration on the Earth's surface. Fine? And now we have to use the formula for the length of second pendulum. What formula for length of second pendulum you have? So length of second pendulum, that L is nothing but your length of second pendulum formula I can write down as a L is equal to G by pi square. So for Earth, I'll say LE. So here G will be replaced by GE. Similarly, I can write down the length of second pendulum on the Moon surface, which is equal to Gm. So for Moon, I'll say capital M. So Lm is equal to Gm upon pi. And now I can see here pi square is a constant. So in first relation, what do you can say? Length on the Earth's surface, length of second pendulum on the Earth's surface is directly proportional to Ge. Similarly, length of second pendulum on the Moon surface is directly proportional to the gravitational acceleration on the Moon surface. So I'll say this is my equation 1 and this is my equation 2. I will divide equation 1 and 2. So I'm getting here Le upon Lm is equal to nothing but Ge upon Gm. And now I'm going to substitute the value. So now on Earth's surface length is 1 meter divided by Lm, which is equal to Ge divided by Gm. Gm is 1/6 Ge. So this Ge factor will get cancelled. And what I'm getting? I'm getting 1 upon Lm. This 1 divided by 1/6 means 6 will goes to the numerator. So what I'm getting 1 upon Lm is equal to 6. So the length of second pendulum on the Moon surface is equal to nothing but 1/6. Clear? So this is your MCQ answer. So length of second pendulum on the Moon surface, that answer is nothing but your in your MCQ. See here your option number. What I'm getting here, option number 1/6 meter. 1/6 meter is option number 8. So for your third MCQ, your answer is A. Okay, next. Fourth one is two identical spring constant K are connected first in series and then in parallel. So two identical springs are first connected in series. So let's consider for spring, there are two springs of identical spring constant. So there is identical spring constant, I can say K. They are first connected in series. So 1 upon Ks is equal to 1 upon K plus 1 upon K. Means what I am getting here? I will get it here. 1 upon Ks is equal to 2 by K. So only Ks that I am going to write on K by K. Clear? Then they are connected in parallel. Afterward, they are connected in parallel. So when same spring, two spring having spring constant, similar spring constant K, they are connected in parallel. So you will get it here, Kp is equal to nothing but K plus K, which is equal to your Kp is nothing but equal to K. So this is my spring constant in series. This is my spring constant in parallel. Right? And now what you want to calculate? You want to calculate here a metal block of mass m is suspended from their combination, the ratio of their frequencies to the vertical oscillation. You have to find out the ratios of their frequencies. Right? So now we are knowing that omega is related to force constant. How? Omega is equal to under root of k by n. This is the general formula. Now what do you mean by omega? Omega is equal to nothing but 2 pi n is equal to under root of k by n. Means what I can say that frequency formula is 1 upon 2 pi under root of k by m. This is the general formula for frequency. Now I write same frequency formula in series and parallel combination. So what I write? In series, I will write ns. For series, I will write frequencies ns is equal to 1 upon 2 pi under root of ks upon m. Get it? Any doubt? Now, same spring constants are connected in parallel. So what I write? Np is equal to 1 upon 2 pi under root of kp upon m. And now I am going to take the ratio of these two. So ratio of these two means, suppose I am saying that this is equation 3 and this is 4. So I will divide equation 3 by 4. So I will get it ns upon np is equal to, just see, if I divide these two equations, 1 upon 2 pi from third, 1 upon 2 pi from fourth equation will get cancelled. Mass factor also gets cancelled. So what is remaining here? Ks upon kp. And we have find out this Ks and kp. What is Ks? Ks is k by 2. What is kp? Kp is 2k. So I can put it here as a k by 2 divided by 2k. So this kk factor will get cancelled. And what I am getting is 1 by 2 divided by 2, which can be written as square root of 1 by 4. And square root of 1 by 4 is nothing but 1 by 2. Means what I am getting frequency ratio? Frequency ratio I am getting as a 1:2. Clear? So see that what is your option number here? 1:2 means your answer is your B option. Clear? So this is about your fourth MCQ. Now see your fifth MCQ. In the fifth MCQ, you have given one graph. So I will draw that graph here. So in this graph is given of displacement versus time. So here your graph is there for displacement versus time. And your graph is a sine waveform. It is a sine waveform. And in this sine waveform, they have given the period marking. Here is your t by 4. At this point, here t by 2. at this point. Here it is given as a 3t/4. Here complete period t. Then here is nothing but 5t/4. Clear? So like that now. Now, what is your question? Graph shows the variation of displacement of a particle performing SHM with respect to time. Which of the following statement is correct for the following graph? Clear? Now, in this graph, what I can say that this is the mean position. I will say mean. It is positive extreme. Here again mean. This position is a negative extreme. Here again mean. Here again positive extreme. And here is again mean. And now we can read option 1 by 1. What is that? Acceleration is maximum at time capital T. Capital T, here is the capital T. Capital T time period is at mean position. And we are knowing that in SHM, at the mean position, velocity is maximum and acceleration is minimum. So automatically your first option is wrong. Second thing is, the force is maximum at the time 3t/4. 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 Search here. Here is the 3t/4. Here is the negative extreme position. Now, when your particle is moving to and fro, so see here, when your particle is moving to and fro, so what I can say that this A point is a negative extreme point. So when particle is moving to negative extreme point, at that time, here potential energy is maximum. So particle is eager to come back to the mean position. Means at that point, the force acting on the particle, restoring force acting on the particle is maximum. Right? So your B option is the correct option. Just we can verify next one. C. Velocity is 0 at time t is equal to t/2. Here, at t/2, your velocity t/2 position is mean, and at mean position velocity is maximum. So automatically C option is wrong. I can go for third one. D option. Kinetic energy is equal to total energy at the time t/4. T/4 here at extreme point. At extreme point, potential energy is maximum. Kinetic energy is 0. So it is not possible. So automatically which option is correct? So your option correct is nothing but the B option. Fine? Okay. Okay. Students, see that for first MCQ. Have you got that answer? What is given? At the instant, its period is half of the maximum speed. Its period at that time instant, its speed V is equal to half of the V max. That is given in the first MCQ. V is omega under root of a square minus x square is equal to half V max. V max is equal. From both the side, omega factor will get cancelled. Squaring both sides, a square minus x square is equal to 1/4 a. What I want to find? I want to find x square. So I shift this x square here. So what I am getting here, it is a square minus 1/4a. So what I am getting here, it is equal to 3a square by 4, which is nothing but x square. So automatically what I am getting value of x? X is equal to √3/2 into a. So at this displacement, your velocity of a particle performing SHM is equal to half of the maximum speed. Fine. So for this, your option number is your option A. Get it? So these are your 5 MCQ. Okay. Now I can go for the numerical problem, which can be asked for either for 2 marks or 3 marks. So see that numerical problem number 8. At what distance from the mean position, the speed of the particle performing SHM half its maximum speed? Just now we have performed that. First MCQ. First MCQ and this problem number 8 is same. At what distance from the mean position, speed of the particle performing SHM is half of its maximum speed? Just now I have found out that x is equal to root 3 by 2 into a. At this distance, your speed v is equal to nothing but the half of the maximum speed. Only the thing is here amplitude is given, sorry, path length is given. Length of the path is given, path length is given. And your path length is nothing but the twice of the amplitude. So path length is equal to twice of the amplitude and which is given as your 10 centimeters. So automatically 2a is equal to 10 means a is equal to 5 centimeters. And now that a value I am looking here. So what I am getting? X is equal to root 3 by 2 into 5, which is equal to 2.5 into root 3. And you are knowing root 3 value is how much? I have told you that you have to remember certain value, root 2. Root 2 is what? 1.414. Root 3, 1.732. Well, put that value 1.732. And just multiplication by 25. So 25 2s are 50, 5 carry, 25 3s are 75 plus 5, 80, 8 carry, 25 2s are, sorry, 25 7s are, is nothing but 175, 175 plus 8, which is equal to 183, so 3, 18 carry, 25 1s are 25, 25 plus 18, that is 25 plus 10 is 35, 35 plus 8, 35 plus 8 is 43. Right? So that 43 has added here and decimal point there 4 decimal digit. So it is 4.33. So that is nothing but your displacement. Okay, have you got this point? X कैसे मिला? MCQ just now before this numerical problem I have taken that MCQ and that MCQ you have to find out the displacement where the speed of the particle is half of the maximum speed. That's why I have not done again that definition. Getting? Okay. Then, next, problem number 9. In that problem number 9, in SI units, the differential equation of the SHM is d square x by dt square is equal to nothing but 36x. d square x by dt square is equal to minus 36x. Find its frequency and period. You have to find out frequency and you have to find out the period. Very simple. Now what we are going to use? This equation is nothing but your differential equation. So I can write first the standard form of differential equation. So your standard form of differential equation is d square x by dt square, which is equal to nothing but omega square x, which is equal to minus omega square. First equation, second equation. Second is the standard form and first is the given form. So if you compare left hand side d square x by dt square of both is equal to right hand side first equation minus 36, lower equation minus omega square, x as it is. So what we can say, omega square is equal to 36. Omega square 36, so omega is equal to 36 is square of which number? 6. So omega is 6. Now if omega is 6, now simple, what do you want to find? Frequency and period. So omega formula is what? 2 pi m. Means what I say, frequency n is equal to omega upon 2 pi. And what is omega? Omega is 6. So 6 upon 2 pi, which is equal to nothing but 3 upon pi. And pi value is what? 3.142. So 3 upon 3.142. Now it is a constant. 3 is a numerator. and denominator is 3.142. Your numerator is less than denominator. Means your frequency value here, whatever division comes, that division is definitely less than, right? And now what I want to find period. Period is nothing but the reciprocal of frequency. So reciprocal of frequency is 3.142 upon 3. So that division I can do. 3 ones are 3. 0.1 is not divisible by 3, so 0. So I'll take 14. 14 divided by 3 means 4 3s are 3 4s are 12. 14 minus 12, 2 is remaining. Number becomes 22. So here 3 7s are 21. So your answer comes, your period T is nothing but 1.047 seconds. And your frequency value is less than 1, means it is comes in the 0.9 में कुछ तो भी answer आएगा. Got it? So this is about your problem number 9. Okay, now problem number 10. A needle of swing machine is moving along a path of amplitude 4 cm with frequency 5 Hz. The needle of swing machine is moving up and down in vertical way. So this is nothing but your linear ascension along the vertical direction. And in that swing machine, you have given its amplitude is nothing but amplitude is given as a 4 centimeter and frequency is given 5 Hz. So amplitude is 4 centimeter and frequency is given as a 5 Hz. And what you want to find? Find the acceleration 1 by 30 seconds after it has crossed the mean position. You want to find out acceleration. When time will be 1 by 30 seconds when it passes from the mean position. Clear? Now, I want acceleration. So I write first acceleration formula. Acceleration is equal to minus omega square. This is my acceleration formula. Clear? Now first what I want to find? X as a displacement. Fine? So for displacement, when it passes through mean position. Got it? So what I will do now here? I will write displacement equation. Displacement equation is what? Displacement x is equal to a sine omega t. Why I will write only omega t? Because your particle is passing through the mean position. This particle has started its motion from the mean position. And when particle will start its motion from the mean position, alpha is phi is equal to 0. Phase angle is 0. Therefore, I am getting acceleration is equal to minus omega square a sine omega t. And now here I am going to put the getting. So now omega square, instead of omega square I put the value of omega. So omega value is 2 pi n square into bracket a है आपका 4 centimeter. So I will say that if I want the acceleration in the CGS system, so I will say here 4 into 10 raised to minus 2. Then sine omega is nothing but 2 pi n into t. And frequency is given 5. Time period is also given, which is equal to 1 by. Here frequency is given 5. So how much I am getting? 10 pi square. So it is 100 pi square. In bracket 0.04. Sine. Here is 10 pi divided by 30. Means I am getting here sine pi by 3. Sine pi by 3 is nothing but sine 60. And for sine 60, I will write down here acceleration is equal to 100 pi square 0 in bracket 0.04 sine 60. Sine 60 is nothing but root 3 by 2. So this 2 and this will get cancelled as 0.02. 0.02 multiplied by 100 means I am getting 2 pi square root 3. Right? अगर pi square value approximate मैंने 10 लिया, multiplied by root 3 value is 1.73. This is nothing but my acceleration. So what I'm getting here, 20 multiplied by 1.732. And just do the multiplication. 0 as it is and by 2 are multiply. So 2 2s are 4, 2 3s are 6, 2 7s are 14, 1 carry. Here it will now 3. And decimal point will be how much? 3. So 34.64 meter per second. That is nothing but right? Here. Very simple. Only what the thing you have to remember. In the numerical problem it is given. Calculate the acceleration after time instant 1 by 30 seconds when it will just pass through the mean position. Just pass through the mean position means what? You have to take the displacement equation of the particle when particle will start from mean position. And when particle will start from mean position, its initial phase angle is always 0. Therefore, your displacement equation is only x is equal to a sine omega t. Finished. And rest of the things are given in the problem. No problem. Right? Okay. Fine. Next. Next thing, what is given? Problem number 11. In problem number 11, it is given the potential energy of a particle performing linear SHM is, you have given